So today we're talking about a thing called proportion problems. Proportion problems have two equal ratios. So that taps into yesterday. So what were ratios mainly yesterday? We had four ways we could write them, but what mainly was the most common way we wrote ratios?
Oh, number equal to number.
That wasn't the most common way, that was in there.
Fraction.
Fraction was our most common. So another way we could say this today is that there's two equal fractions. So this fraction equals that fraction, all over the board, this fraction equals that fraction. If you have two equal fractions, two equal ratios, that can be called a proportion problem. There's a bunch of ways we can solve these proportion problems. So this group is going to involve math we already know. This group's going to involve two maths we already know. But by the time we get over to the third column, I'm going to need to teach you new math today. Okay, but these first couple columns, you could do these already without me teaching you anything new. What we're hunting is the letter. Okay, we remember hopefully what that's called. A letter's called a variable. So we're trying to come up with what is the missing number in these proportion problems. Can anybody for this one, without having to learn new math, tell me what is the missing number? This is an 8. Can somebody other than him who got the 8 explain how he got the 8?
Multiply 4 by 2.
That's correct. Okay, what thing is this that we've learned this year? It's the name changer machine. Sometimes we can use the name changer machine to figure out proportion problems. Other books will call this equivalent fractions. But the idea is he figured out that the top got multiplied by 2. So then you just have to multiply the bottom by 2. So if they multiply the top by 2, you multiply the bottom by 2. And you can come out with 8. If we go to attack this one, this time they didn't multiply the top, they completed the bottom. They multiplied the bottom by 3. So you multiply the top by 3. And that's 24. Did anybody get confused? Anybody need help on this first pair? So this, they multiplied the top by 3. They multiplied the bottom by 3 also, but they gave you the finish instead of the start. What number would have to be true at the start to make this multiply by 3 sort of thing work out? It would be 8. Another way you could do this would be by thinking dividing. If you wanted to work this way, they divided by 3. So you could divide that by 3. Whether you're thinking about multiply or divide, it doesn't really matter that much. But on this, to make this be a truth, what would be the missing number in that slot? Not quite. 6 is involved. 6 is being used, but that isn't the 6.
2.
This is going to be a 2. They multiplied by 6, so you would need a 2 here to withstand that multiply by 6 to turn into the 12th then.
Oh, but doesn't 3 go into 18 6 times?
It does, and 2 goes into 12 6 times.
Oh, okay. I was
Did that click?
Yeah.
Question left of the line, those just use the name changer machine. That's math we had. Sometimes that works. Won't always work, but I know sometimes work. Question about those? Okay, when we cross the line, why does that not work so well anymore?
4 can't go to 6.
4 doesn't go into 6. So there's no like whole number that 4 could multiply by to make 6. For 4 to make 6, there's some kind of fraction or decimal or something like that involved, and life maybe got a little more complicated. Can anybody think of a way to use math we already know, though, to still do this? Reduce the first fraction. Sometimes, if you reduce the first fraction, then the name changer machine is going to come into play. 4/6 is the same as, if you reduce 4/6, 2/3. Now the name changer machine works. They multiply the top by 3, so multiply the bottom by 3,
9.
and that's 9. Question about that. Okay, here you can't immediately do the name changer machine. 10 can't go into 15. It just doesn't cooperate. But 8/10 is reducible. If you reduce 8/10, what's 8/10 going to turn out to be?
4.
4/5? And if we've got 4/5, now things work out well. 5 can be turned into 15 if you multiply by
3,
3. So match that on the top,
12.
12 will work. Here we're out of luck, 15 and 24 are not friendly, but we can reduce 24/40ths. If we reduce 24/40ths,
Twelve
12/20 is pretty good. Okay, that's going to be better. 12 still won't play nicely with 15, but we're in the right direction.
6 over 10.
Okay, we could go 6/10. That's better again. But 6 and 15, they still don't play well together.
3 over 5.
Ultimately, 3/5 is going to play better with its friends. So if 3 is turning into 15, what would 5 be turning into? 25 is correct. Question about anything to the left of that line now. Reducing can sometimes open the door for the name changer machine to work. Anything there? Then I think we'll need to do a turn because I'm probably about to disappear. We want to capture all the way to that line if we can.
Yeah, that's not
Are we good? Got it from line to line?
Yeah.
Good to go? All right. So this we need to learn some new math today because we have a situation here where 5 can't go into 7. That's not going to work. 3/5 can't reduce. That's not going to work. So I'm going to teach you a math skill called cross multiplication. Cross multiplication means you're going to multiply the numbers that are diagonally from each other. In other words, 3 wants to try to multiply 7. So 3 times 7 makes 21. When 5 tries to multiply x, they can't really multiply because they're different kinds of things. Numbers can't really multiply variables, but we can just write them side by side. Okay? If we write a number next to a variable, 5x is our best solution for that. I don't know that you've ever done this before, but working from here forward, we've done before. But multiply diagonally, that's called cross multiplying. These make 21. Those make 5x. Just write a problem that looks like this. We've done these problems before now. How have we done this before? We go 5 divide into 21. 5 into 21 goes 4 times. And then you have a choice with what you want to do about your remainder. What's a thing you could do with your remainder here? Just make it 1/5, and that's what I would encourage. That's the easiest thing. Put the remainder on top of the divisor, make a fraction, and be done with it. What's another thing you could have done? Made a decimal, but then you have to divide till it either
Ends.
or repeats, and it might be a while. And I'd rather not do that because it sometimes this would happen right away. This would be 4.2, no big deal. But we've done the 7s before and some other ones that it can take a while. Question about that? That's new to our life this year. So this, we're stuck with this new scheme. 5 won't go into 8, 5/6 can't reduce, so we'll cross multiply. What's one thing we'll get off of one of the pairs? There's a 48. 6 times 8 is 48. That doesn't matter if you write that first or last, just write it wherever. What's the other pair going to make? 5x. So 5x from this pair, 48 from the other pair. Then we need to divide 5 into 48. Anybody in a dividing mood?
Okay, 9.
9 is true, because 5 times 9 gets you close with
45.
45. Remainder,
3.
3. And personally, I prefer fraction. Fraction would be 3/5. Question there. So one more time. Cross multiply. What's one of the pairs? 22. 2 times 11, 22. The other pair?
3x.
3x. The finish it, we've got to divide by taking
3, 26.
42, goes
7,
7. 7 gets us to
21,
21,
100.
1/3. I agree. Question about those? The nice thing about this, it will always work. The name changer machine won't always work, but it's nice if it does because it's quicker. But that won't always work. But I could go back to where we started, and why don't we turn me? Why don't I go back to where I started, if you can turn me back to where I started, all the way back to here. If we wanted to go back to this one, if you want one system that'll do everything every time, just do the cross multiply system. Because what's one of the pairs we'd get off of this? 24. Those make 24. This pair makes
3x.
3x. Then we'd want to divide,
3,
and
24.
that'll go
8.
8. Okay, so if we went and reworked that system earlier on any of these problems, it would work for all
So
of
we
them.
can do
Cross
that?
multiply would work every time. So if you like cross multiply and you want to practice cross multiplying, every problem cross multiply would work. If you like the name changer machine more, because that's familiar, it'll sometimes work. Sometimes it won't. You never know. Question
So you
about
just,
that?
so like, 8, 10s, and 30.
So
You just
here we multiply those.
Oh,
That's 8 times 3 is 24, but with a bonus 0.
Yeah.
Multiply the other pair, that's 10x.
Uh,
And then if you divide 10 into 240, it's 24 every time.
Okay.
It'll work every time.
yeah.
Question about how the new thing can work on the old ones too. The whole board could be done by cross multiply. And we'll turn view while I slide all the way back. The last little group, we're going to compare fractions again. It's been a while since we've compared fractions. Early in the year, what was one way we used to compare fractions?
Stop.
Yeah, maybe. We could turn them into decimals
Yeah.
and then compare the decimals. That is a thing we did.
Yeah.
What's another way we compared fractions?
Like we changed the fraction.
Yeah, to make them have a
Equal denominator.
common denominator, and if you're going to change the bottoms, you have to
Change the top.
change the tops. We've done that before. Those are perfectly good. Those are probably more memorable. But this is the quickest way we could do it, but sometimes people forget this trick, so it's maybe not the best trick because people forget it. Okay, but we can use this same idea of cross multiplication by doing a thing called the cross product. If we go to do the cross product, we'd want to multiply 2 by 10. 2 times 10 makes 20. This time though, it matters who goes on what side. I told you as we worked these, it didn't matter which side you put the numbers on. This, we have to put the right number on the right side. The top is the boss. So 2 times 10 makes 20. Put the 20 over here because the 2 is going to keep that because the 2 was the top number. The top number is the boss. What number would turn out on this side?
7. 7. 70. Wait.
Somebody I think just said it. 21. How'd you get 21? 7 times 3. 7 times 3 is 21. 7 keeps that because the top number is what keeps the number. Well, we're going to multiply diagonal like we were over there, but I'm going to erase this because it's creating clutter. Okay, but 2 times 10 made the 20. 3 times 7 made the 21. And then you go that way because 21 is bigger. So what's the number for on this side? $25. The 5 is the boss because it's on top. 5 times the other 5 because we're multiplying diagonal, we're multiplying across. 3 owns the other side,
24.
24. And then you go, what symbol is that?
Greater.
Greater than, because 25 beat 24. So who's over here?
30.
30. From 6 times 5. Who's over here?
28.
28 is 4 times 7. So,
Greater than.
good.
Greater.
Question about that? If you can remember it, that's the quickest way to compare fractions. Something about it? Let's take a look at where we're going. First page, in terms of being earlier in the book, we're gonna go do a 176. On 176, we're gonna do the letters, but I think we have to ignore the directions. The 176 letters have us comparing fractions, but I wanna do it with cross products. So we are gonna ignore their directions. On the 176 letters, we already did these a different day, but when we did them the first time, we compared these by making them decimals. We're not gonna make them decimals, so don't obey the directions on 176. On 176, I'd wanna see the two numbers that are the cross product numbers, this versus this, and then a symbol in the middle. You don't have to write down the original fractions if you don't want to, but you need to write down your two created numbers by multiplications, and then a greater or less in the middle. So your answers would look like only the parts that I'm circling. So 176 letters, do the cross products, ignore the directions. That's the way to do that. Then we're going to go to the back. Set KK is going to be probably your favorite set from the back because I think they made a mistake. Anybody look at set KK? Anybody notice what mistake I think they made by accident, but you're not going to complain about it? What'd you say? Yeah, it goes to 20. Every other set in the book has gone to 25. The one day we had a set that went to 24 because they were going in groups of 6.
That was the easiest.
So we had a couple 24 sets when they were doing problems in groups of 6. But yeah, for some reason today they went to 20 and then just like stopped. So
Let's go.
yeah, I don't think anybody's got to complain about that. So 176 letters to KK. That's our day.